In this video, we're going to solve word problems that involve using quadratic equations. And in this first video, these problems are going to be word problems where we need to find numbers. So for example, what I mean by that is this first example says the product of two consecutive positive odd integers is 99. Find the numbers. Okay. So we're going to think about what's given. And we've got a couple of things that are given. We're given the fact that we have two consecutive positive odd integers. So we're going to have to think about what that represents. And then we also know that the product is 99, right, of the two. So the product is 99. So we're going to use a algebraic equation, and that means we're going to use a variable. So we need to define our variable. And we're going to, we're missing two numbers, right? We're trying to find two consecutive odd integers. But we only have one variable, so we're going to let x represent one of the two numbers. And I'm going to let it represent the smaller of the two integers. Okay. All right. And so then we need to think about what it means to have two consecutive odd integers. So consecutive means that they're one right after the other, right? And if they're consecutive odd integers, then here are some pairs of consecutive odd integers, 1 and 3, right? And 3 and 5, and 5 and 7. So these are pairs of consecutive odd integers, right? And so how far apart are these two integers? So in 1 and 3, 3 is 2 units away from 1. And 3 and 5, 5, which is the larger of the two integers, is 2 units away from 3. Okay. And 5 and 7, 7, the larger integer is 2 units away from the 5, right? So for us, if x is the smaller of the two integers, then x plus 2 would be the larger integer. Okay, because now we would have x and x plus 2 as a pair of these consecutive odd integers over here, right? They're 2 units apart. So now we need an equation, and the equation involves the fact that we know that the product is 99. So that means product means multiply these two. So the equation would be x times x plus 2 equals 99. So the product, so multiply, equals 99. Okay. Now, to solve this equation, first we need to distribute the x. So we're going to get x squared plus 2x equals 99. And this is a quadratic equation. And to solve it, we need a 0 on one side. So we're going to subtract the 99. And now we have a quadratic equation in standard form, and this one factors, doesn't it? Two numbers that multiply to a negative 99 and add up to 2 would be x with a plus 11 and x minus 9. Okay, and now we're going to use our zero factor property and set these to 0 and solve for x, right? So x plus 11 equals 0, or x minus 9 equals 0. And here we get x equals negative 11. Okay, so let's talk about this solution. What did we know about our two odd integers? Well, if you come back up here, they told us that the integers were positive. So this x cannot be negative 11. So this solution we need to toss, right? This one, however, gives us that x equals a positive 9. So if remember that x is our smaller integer. So to find the next integer, we add 2. So that would be 11. So 9 and 11 are our pair of integers. Are they odd? Yes. Are they consecutive? Yes. 9, 11, right? And do they multiply to 99? Yes. So these are our two integers. So the conclusion statement would be that the two odd integers are 9 and 11. That'd be good. Okay, let's look at the next one. Very similar. We have the product of two consecutive, but they're even. And then it says whole numbers. And just a reminder to you that the whole numbers are the numbers that start with 0 and they go up. 0, 1, 2, 3, 4. These are called the whole numbers. Okay? This set of numbers. So that means that just like the last problem, our two integers will be positive, right? So we're going to let x, once again, represent our smaller integer. And because pairs of even numbers are 2 away from each other, we will write x plus 2 is the larger integer. Right? Because again, let me remind you, pairs of even integers, 2 and 4, 4 and 6, 6 and 8, right? These are consecutive even integers and they're 2 units away from each other. Okay, our product is 840. So again, we're going to take our small integer x, multiply times the larger integer x plus 2, and that equals 840. And then we're going to distribute. So x squared plus 2x equals 840. And so we've got, again, a quadratic equation that is not in standard form. So we're going to subtract the 840 and get a 0 on one side. And this factors. And that's x plus 30, x minus 28 equals 0. And again, we're going to set these to 0. So x plus 30 equals 0. This one's going to give us x equals negative 30, which is not a whole number because the whole numbers are positive, right? Okay. 0 plus the positive numbers. Okay. And then x minus 28 equals 0. That gives us x equals 28. And so this is our smaller even integer. So our larger integer add 2. And that would be 30. So our pair of integers are 28 and 30, and they multiply to 840. By the way, if you couldn't see this factoring easily with the big number, with the 840, then I just want to remind you that you can use the quadratic formula for this quadratic, and you'll get the same answers, 28 and 30. Okay, let's go to number 3. This one says the difference of two positive numbers is 7. So the difference of two positive numbers is 7. The sum of their squares is 85. So these aren't consecutive odd or even numbers necessarily. You just know you have two numbers whose difference is 7. And then the sum of their squares is 85. Find the numbers. So let's let x be the smaller integer. Smaller positive number. Okay. Then the fact that you know that the difference of the two numbers is 7, what does that tell you about the larger number? How far away from x must it be if the difference is 7? Well, if you said 7 units, then you're right. So that means that x plus 7 is the larger positive number. Okay? Because notice if you subtract these two, you get 7, right? If you take x plus 7, subtract x, you get 7. Okay? So now for the equation though, we're going to use this given. The sum of their squares is 85. So the square of x is x squared. And then the square of the larger is this binomial x plus 7 squared. The parentheses is important. And it's telling us that the sum of that, so add those two and you get 85. Okay, so now we need to expand this binomial here. So if you are thinking of foiling, first, outer, inner, last, then you're right. So I'm going to go ahead and write two of these. So this guy is x squared. And then over here we get x squared. The outers give us 7x and the inners give us 7x. So we get plus 14x. And the last give us 49. and that's going to equal 85. And then we're going to add some like terms here and get a 0 on one side. So add these two x squares and you get, so then here we go ahead and add the like terms. We get 2x squared plus 14x, and then we have negative 85 plus 49, which is a negative 36, and that equals 0. And now I notice that all these coefficients are divisible by 2, right? They're all even. And since we have an equation, I'm going to go ahead and divide everything by 2, both sides of the equation, to make the number smaller. So we get x squared plus 7x minus 18 equals 0. Okay, and this factors x plus 9, x minus 2 equals 0. And here we get x plus 9 equals 0. So here we're going to get that x equals negative 9. Can we keep that answer this time? Well, I'm going to remind you that the numbers were positive, right? So we cannot keep that. And this equation here gives us that x is 2. So our smaller positive number is 2. And then you add 7 to get the larger. So the two numbers are 2 and 7. Now, excuse me, not 7, and 9. Because remember, x is 2 and x plus 7 is the larger number. So 2 plus 7 is 9. And now let's check this, because it says that if we square these two numbers and add them together, we should get 85, right? So let's see, let's check that here. So 2 squared plus 9 squared, we're supposed to get 85. So 2 squared is 4 and 9 squared is 81. And yep, that's our 85. So that definitely checks. So our two numbers are 2 and 9. Okay, one more example. Okay, this one says two whole numbers. So remember, the whole numbers are 0, 1, 2, 3, and so on, right? So positive. Have the following relationship. One number is 3 more than 2 times the other number. 3 more than 2 times the other number. The difference of their squares is 144. Find the numbers. So we're going to let x be the number we know nothing about. One number. And then what do we know about the second number? Well, that it is 3 more than 2 times the other number. So 3 more than 2 times. So 2 times the other number would be 2x. And then 3 more would be plus 3. And that would be the other number. Right? So x is the number we know nothing about. And then 2x plus 3 is the number from the second sentence, right? Okay, so now it says here that the difference of their squares. So we're going to subtract these two. Which number do you think is bigger, x or 2x plus 3? If you said 2x plus 3, you are right, since these are whole numbers, right? These are positive. So since my equation is going to involve subtraction, right, because it says difference, I'm going to put the bigger number first. So 2x plus 3 squared, subtract, because they wanted a difference, x squared, that's equal to 144. So the difference of the two numbers squares, see that? The difference of the squares is 144. So that's how we set this up. And now we're going to have to expand. So this one needs to be, you have to write 2 of those and use your foiling, your f first, outer, inner, and last. So what do we get here? 4x squared. And then the outer is 6x and the inner is 6x, so plus 12x. And then the last is plus 9 minus x squared equals 144. Okay, we're going to combine like terms here and subtract the 144, get a 0 on one side. So the 4x squared and the minus x squared is 3x squared. The 12x. And now I'm going to subtract 144 from the 9 here, right? So subtract 135. That equals 0. Wonder if 3 goes into 135, because wouldn't it be nice if we could just divide all those by 3? And you know what? It turns out that it does. So let's do that first. Okay. So here we get x squared plus 4x minus 45 equals 0. Okay, that looks a little better, doesn't it? So now we're going to factor. And this is going to be x plus 9, x minus 5. And remember, we're going to keep the positive answer because they wanted us to find whole numbers. And whole numbers are the numbers 0, 1, 2, 3, 4, and so on. So they don't have negatives. So this first x plus 9, that's going to give us x equals negative 9. So we're not going to use that. This one gives us x equals 5. What did we just find? So we found this number, x equals 5. Okay, so to find the other number, we're going to substitute the 5 in here, right? So 2 times 5 plus 3. So 10 plus 3, 13. So the second number is 13. Now, I wonder, let's check and see if when we square these two numbers and subtract them, we get 144. So 13 squared minus 5 squared, do we get a 144 here? So let's see. So this is 169 minus 25. And guess what? That checks. So the two numbers are 5 and 13. 5 and 13 are the two numbers.